much. Good morning, everyone. It's a great pleasure to be here today, especially with my colleagues here, Michael, Rodrigo, Piotr, and Christina, to discuss a very interesting project that we've been working together, collaborating for the past 3 years. And before we start, I'd just like to give like a quick round of introductions so you know who we are and from where we come. But my name is Roger Diaz. As it was presented, I'm assistant professor of emergency medicine at the Harvard Medical School, and I did a research lab. And this project started as a research grant, as an idea, and thanks to the collaboration between the academia, our university, our hospital, and industry partners, we were able really to design, develop, and implement this very interesting project related to medical training for astronauts. And we're going to give a lot of details about that. And our main goal is really to share with you what we learned and the challenges we had and how we solved those challenges. And hopefully you can learn from our problem solving and what we learned through these 3 years. So I'm going to start with Michael here giving some initial introduction and then go to the panel.
Thank you, Roger. And I want to say I'm humbled and thank you very much for investing your time to learn about us and what challenges we face and how we did it. I'm Michael Mansouri. I'm co-founder and CEO of 2 companies. One is Radiant Images, and Radiant Images, we are a hybrid of a production company creating content, as well as enabling content creators to dare mighty things. Another company that we formed that I'm part of as CEO is called WebMo. And WebMo is a remote collaboration platform that allows us to create connections between people, devices, and ideas, all in real time, and we virtualize the content creation and distribution. So an example of what that means is the cameras that we have here, these could all be virtualized, so we can virtualize the entire process of content creation from pre to production to post by connecting these cameras to the cloud and then remotely being able to control and distribute so we don't have to bring infrastructure in. So WebMo's philosophy is to remove some of the friction and barriers for content creation and distribution. And we were introduced to Roger and Stephen and Chuck, who's not here with us, about, I think it was almost 4 years ago, 2018, about this concept. And it's an honor to be here to finally see it happen and sharing this experience with my partners who made it possible, Roger, Piotr, and Christina.
Now, Rodrigo, introduce yourself.
Sure. Hi, my name is Rodrigo Cerqueira. As Roger, I'm Brazilian. And it's crazy that we're here talking about this project. Yeah. Just thinking about it, like 3 years ago, I was launching my VR film. I produce and direct a film called 7 Miracles, which was a hybrid film, 360 and volumetric. And when Michael told me about the idea behind what we're going to talk to you about today, I was like, yeah, but wouldn't it be great if we do this using the latest technology, volumetric video, you know, environments in 3D? He was like, yeah, but I'm not sure if we're going to be allowed to do it. So let's start this conversation. So then we went to meet Roger, and you hear about it. But basically, I'm the CEO of Panograma. Panograma, it's a company that it's like a creative agency or a creative studio. We do things for VR for about 9.5 years so far. And we've been collaborating with Michael since, I don't know, 2015, 2016. Yeah. But this was the very first crazy, beyond crazy project that we did together.
Yeah, I think so. Thank you.
Piotr?
Hi, good morning. Thanks for coming to the panel at 10 a.m. My name is Piotr Uzarowicz. I'm responsible for partnerships at Arcturus. Arcturus developed a software package for volumetric video, post-production, and streaming, and became quite an important tool in the development of this project. There was a lot of learnings along the way, a lot of cool things and challenges that we faced that is now helping us evolve the product into more exciting and new ways to kind of facilitate more experiences like this for others to create other projects like this. And so we'll touch on that in a little bit. And of course, I welcome you to come visit our booth on the floor where you can kind of see some of those demos and examples in action in our booth.
I'm Christina Heller. I'm the CEO of Metastage. We are the volumetric capture studio where we shot the human performances that were integrated into this training experience. And I'm a big advocate for volumetric video for training. It brings the level of like authenticity and realism and presence to training experiences. And particularly if you're trying to teach about the nuances of any kind of behavior, I think volumetric video is a great tool for that. So it was just a huge honor to work on this project, and I'm really, also grateful to be on the panel with all of you.
Thank you. Thank you very much, Christina. And we're going to certainly touch base on our decision process, right, to use volumetric video for these experiences. But I would like to start giving you like the background about this project, right? So first of all, I would like to acknowledge that in addition to the 5 of us, there are probably 15, 20 other collaborators that work together in this project and make this happen. Unfortunately, they're not able to be here, but they will all play an important role in this project. As I mentioned as well, and that's an interesting thing, right? So the project started in an academic institution and as a research grant, right? So it's not that we had the technology and then you say, okay, how are we going to use this technology? Let's find a way to use the technology. It was the opposite, right? We had the problem to solve. That was this grant solicitation from NASA, from the TRISH, that's a Translational Research Institute for Space Health. That's basically the institute that manages a lot of the NASA research grants. And as such a project, they were interested in specific things. So all the NASA and space health and space in general research is driven by specific needs, specific risks that are inherent to space travel, and specific gaps that the NASA team mapped throughout all these years. What are the scientific gaps? What are the development gaps? What are the design gaps that we need to fill in order to decrease risk and to mitigate the risk that will be inherent to any space travel, right? So the project started with this grant solicitation that was looking into the fact that one of the more than 20 different risks, one of them is the risk related to the occurrence of medical conditions, medical events in space travel, right? That's a very important risk for orbital missions, for lunar missions, and especially for long duration, deep space missions like Mars, right? We know that medical events happen, they will happen. There are many ways to decrease that risk, for example, through selection of healthy people, but still, the probability is there. And NASA has mapped that throughout the past decades, what are the probability of medical events. And in order to, since we know that's going to happen, right, how can we prepare? Because if a medical event happens in the space missions, the entire mission is going to be compromised, right? In some situations, you can just like do med evacuation to Earth in 4-6 hours, but in long duration missions, that's not possible. Right? In Mars mission, for example, we talk about like a minimum of 2 years, right? So if there is like a cardiac arrest or like a heart attack in the Mars mission, there is no option to come back in 1 week, 2 weeks. It's just not an option. So how can we prepare the space travelers? And now we're talking not only astronauts, right? You're seeing the entire space market, and it's not only astronauts, but space travelers. How can we prepare these people to take care of patients in space missions and mitigate any risk, because that's going to happen, right? And between the different risks, we've been working with NASA for now 6 years, developing training programs using medical simulation, these medical simulation centers, right? All the training for astronauts is based on ground-based institutions. And as you may guess, I mean, they have a lot of things to learn in 2.5 years, and medical care is not a priority as like operational things. So for example, a current training for astronauts has only 40 hours of medical training. So from like the 2.5 years of training for like creating and training an astronaut, only 40 hours, 2 weeks of training in medical care. And if something happens now in like the International Space Station or like an orbital mission, right, they have telemedicine. They can call the mission control, the flight surgeon, mission control, and the flight surgeon can guide the astronauts through whatever procedure, whatever they need to do, because the time delay is not an issue. When you go to the next few years, right, to the Artemis program, like the lunar mission, we'll talk about 4 seconds time delay each way. What to become more complicated, to do like emergency care, having someone on the ground helping you with like 3-4 seconds time delay. But when you go to Mars, we'll talk about 20 minutes time delay each way. So telemedicine, telehealth, and support from someone on the ground is not possible, right? And that's an important risk and gap that NASA is interested to fill. How can we help astronauts to take care of patients in space in long-duration missions? And as part of this, they need to do training during the mission, right? So all their training, as I mentioned, is based on the ground, but for a 2-year, 3-year mission, they need to do refresher training. They're going to forget things in 6 months, 1 year, even if there is a physician on board, right? The physician may be a patient, and then you have a lot of engineers taking care of the physician as the patient, right? So it's a very complicated problem to solve, and training is key. So how can we create solutions that help astronauts to continue doing training during missions, during 1 year, 2 year, 3-year missions, right? And we can't build a medical simulation center in space, right? Can you imagine, I don't know if you're familiar, but that all those large equipment, very expensive, a lot of space. So by aiming to tackle that problem, how can we create scalable, not heavy and large solutions to do training space, that we thought that extended reality could be a great way to do that job, to create interactive and experiential learning activities for astronauts to do training while they are in space missions without the need to build like a huge facility for training space. So that was like really the gap that we're trying to fill with this project, right? But as I mentioned, we had no experience with XR or interactive storytelling, all of that. We were like researchers, we know a lot about medical education and the best learning and teaching methodologies, and we know that, for example, that experiential learning, being immersed and interacting with the learning environment is very important, right? But we didn't have the expertise on developing the tech and developing the scenarios. And it was like during that moment that we knew Michael from other projects, and then we reached out to him and say, okay, Mike, can you help us to design and develop an extended reality platform to provide training for astronauts during space missions, right? And then I'm going to let Michael tell us from that moment, that was like the ideation or like writing the proposal, what happened from that moment until we start actually doing the job. Many people were involved, and Michael.
Thank you. Thank you very much. Yes, so the opportunity came from Roger and his team, and we had to search to find the right technology that is relevant and proven now, and that is also impactful for the mission, which is 2030. It's for when man goes to Mars, man or woman goes to Mars. And how do we create something that is beyond just cool? How do we do something beyond just entertainment? How do we do something that is impactful? So we've had some history and experiences with volumetric with our friends at Uncorporeal. There were early stages of volumetric, and originally the request was like 360 video, and we're like, you know, I think we can push this next level. And what is the next level? And how's it different from a 360 environment? Well, the learner has capacity and capabilities, a freedom of movement, a freedom of exploration. They can navigate in that space, which is a digital double of the environment and a holographic capture of the subject matter. And they could learn through trial and error. And that is the key that we found, that we felt that the technology is poised perfectly for the mission. And it is not in early R&D stages yet. It's kind of worked its way out. Early days was when we were working with companies like Uncorporeal, where it was very early, and it wouldn't be possible to do the amount of content that we needed, because it wasn't just like a short, social media blurb. It was out, 20, 30 minutes of content that needed to be impactful, photorealistic. And at that point, we searched and we recommended moving towards volumetric 6-stop videos. But when we're talking about 6-stop volumetric videos, to most people, it's like describing electricity to someone in the 14th century. It's our problem on in this board. Like, how do we describe it? How do we show this off? How does it make impact? So the first thing we did is I reached out to my collaborator, Rodrigo, who we just finished a movie with, supporting his movie, 7 Miracles, and he took the brave risk of pushing the boundaries beyond just a flat 360 experiences, putting the audiences, living the experiences inside the movie. So now we had a reference that we can show. So I grabbed Rodrigo, we got on the plane, we met Roger and the team, and we showed them, is this the impact? Is this what we want? And they were blown away immediately. They were like, yeah, this completely makes sense, because think about what we can do in volumetric that you can't do in a flat video. I'm the learner, and I need to learn from my subject matter. Well, I can become them. I can put myself on top of their hands, learn through their input. And that is something, that's a medium that we can't get in traditional. And because of the mission, the fact that it was, communication was very difficult, to make sure that the learner had all the abilities without reading a manual, and it wasn't stuck in a linear form of learning, where we're breaking that. We're actually allowing interactivity. We call this branching narratives. And that gave us the philosophy of creating something that has the impact. And part of our core philosophy in WebMo and Radiant is that everything that we do is founded on 3 principles. Is it human? Is it spiritual? Is it purposeful? And we felt that this technology and the scope of the work tapped into all of that. And I'll hand it off to Rodrigo, because he became as our director, and he pushed the narrative forward and created the synergy between story mechanics and the technology.
Thanks, Michael.
Thank you.
Yeah, I need to be honest with you. I didn't know if I told you this, but I had no clue what I'm getting into.
Me too. Yeah, we all do.
Okay. I said yes because I always say yes to you, but
Thank you.
when I come back home, I was like, oh my God. Anyway, it was a great experience, basically, because from the get-go, Roger and the team, they were like, okay, we have it's a clean canvas. What can we do? I was like, I don't know what you guys want to do. And they were like, we don't know. I said, okay, that's cool. So let's learn together. We spent 12 months approximately, right, Roger?
Yes.
Between the moment that we had this grant, the project started, and we were like, okay, what is the purpose of this project? Is to not only to represent what happens in the real life, but also kind of foresee what the input of those users might be. What happened if the users go in this direction instead of that direction? I wasn't at all worried about the tech side of it. I was more like willing to hear and understand and discover what was the core importance of what we're doing. So basically, I was following Rogers and the team that we put together, understanding the hurdles that they have in the real life. Okay, when we do this in our simulator, this is how we do. I said, okay, this won't work. What else? Okay, if this doesn't work, we do this way. I said, well, maybe we can tweak it, and it might work. So we learn from our experience what would work and what wouldn't work for this project. So basically in this 12 months, we have inputs from engineers, doctors, professors, astronauts, pilots, other XR experts as well. And after this 12 months, we came up with, let's say, a backbone of what would be the final project. And with that backbone, we were able to see the entirety of the experience. Then we brought back, and then I said, well, I believe I know the right partner or right partners to do this with us, because we were in like the verge of the boundaries of what was possible. Not only shooting this in volumetric, but also engine-wise. How can we run this through Unity? Or is it Unity the right engine for this, or is it Unreal? Do we need to build something new, or do we use the blueprints that we have? So when that kind of, let's say, kind of questions emerge, I was like, okay, I need to be surrounded with, you know, the best guys in this field. So that's when I reached out to Christina. I was like, Christina, I have something crazy to tell you about if you're open in the next like couple months for this project. And why don't you tell Christina your first thoughts and how we develop this like pre-production and production for the volumetric capture?
Well, real fast, because I actually think we only have a couple minutes left. But
No, we still have 25.
Oh, well then that one. So I was looking at that guy. Okay, cool. Pressure's off. So yeah, I mean, it was honestly, it was the proposition of a lifetime to be able to do volumetric video capture for a NASA training experience. Like, you don't get calls cooler than that. So, you know, for us, it was working with Rodrigo and Michael and Roger on, you know, figuring out the branching narrative component. That was really the biggest, you know, for us, capturing volumetric video is what we do day in, day out. So we weren't concerned about that component, although the branching narrative piece is the challenge, because there's an element of wanting to match the kind of good and neutral poses at the beginning and end of every clip so that they can flow naturally into each other. And also kind of double checking the logic of the branching narrative like map, because you have to, you know, really imagine the script in a new way and make sure that your assumptions are taking all of the user, all of the user's experience into account. And sort of, you really need to do a lot of pre-production with volumetric video. It's not necessarily a fix-it in post ideology. That being said, that is where holosuite comes in, because it does allow an element of fix-it in post. In general, we do recommend, though, a lot of thoughtful pre-production. So for us, yeah, we worked, my amazing team, Skylar Sweetman and the rest of the folks at Metastage worked hand in hand with Rodrigo and Michael to build out the script and think through all of the components.
Cool, yeah. And then we have this problem, because basically when you do a branch narrative and you want to be as seamless as possible, it's like Christina said, it's working on the neutral positions at the very last frame to the same kind of positions of the first frame of the next take or the next scene. And we had approximately like 20 minutes of volumetric video, and we were like, okay, there's two ways for us to do this. It's either I do one shot, one continuous shot of everything, and then I get like the last frame and I just loop it, and then, you know, continue from one scene to another, or we do a cut. But then with the cut, there's a problem, because you need to match those two frames. But with the continuous shot, there's a problem as well. Not for Christina, because we'll rent the stage for 2 weeks. But for us, in terms of budget, it will be a huge problem. So we decided to make the cuts. And that was a big leap for us. And I brought this to the team. I said, I believe I have the best in class to do this. It's my friend Piotr. And then we brought Arcturus.
Yep. And yeah, that was an amazing opportunity, and I'll mimic everything else that, of course, you know, you're going to jump at any kind of opportunity like this and try to execute it to your highest ability. And the presentation of the concept of a branching narrative is something that we've been exploring and thinking about, executed in various formats in earlier productions, but nothing like this at this scale. And the idea, and why do we keep talking about branching narrative? And I think it's important to kind of illustrate this point. The idea was to kind of maintain that sense of engagement and immersiveness in the scene, so that the viewer, the user of this experience would feel engaged in that moment and feel the pressure of that moment and feel the weight of the decisions that they're making. Because once they made that choice, they're then faced with the consequences of that choice immediately. That's that branching narrative, right? So they made a choice, and that choice then puts them face to face with the consequences of the choice that they just made. So that's a really powerful experience to have. And how do you do that on a technical level? And we talked about some of them. One, you can kind of record it all the way through and record all the various versions of it all the way through. But that is very costly, very time-consuming, expensive, any number of reasons why you might not want to do it that way. So for us, the technical concept came up of blending frames together. Now, if you're familiar just with video in general, right, you know that every image is a series of frames. And then the next sequence that you take is also another series of frames. But how do you take this clip that ends with this frame and merge it and blend it with the first frame of the selected clip that that viewer or that astronaut chose and make that part seamless to keep them engaged, right? You don't want a hard cut, you don't want to go to black, you don't want to do anything like that. You want that to be as smooth as possible so that they feel that constant sense of like pressure and engagement in that scene. So that's where some of the technology that we had partially developed and thinking about like, oh, this is where it could go, really forced us with Rodrigo and his team to kind of evolve that further and make that a much more important part of our workflows and software and processes. Because going through this project, we realized how important and how valuable it is to be able to build stories like this. So ultimately, through this partnership, we not only were able to kind of utilize many of our existing workflows, but helped us discover new ones and evolve the software in the directions it needed to go to ultimately deliver this project. So from that perspective, we're extraordinarily grateful and excited about what the final result was.
And we had also to, bring all those parts together, and that was another challenge, because basically, okay, now we have the content. We need to do a lot of visual effects on this content to blend it. We have a great tool to do that, but the budget was, a constraint as well. So how can we use our time, because we have a time limit. Yep. I believe after we shoot and have the first frame from Metastage, we had like 5 months to finish. Yep. So we decided another crazy path to go. Instead of just bring everything to our selected engine, which was Unreal, and just create like every other experience we did. Okay, let's put together, let's create blueprints, and make the decisions on those blueprints, hit build, and do it for Vive, do it for AR, and that's it. And I said, but Roger, if I may, I would like to suggest another crazy thing, which would be, let's spend the next 5 months building our own blueprint. What that means is basically the scenario is built by someone that has the knowledge of the branching narrative, knows which video goes to where, knows the answers, the questions, but there's no tool to do that. You need to do that on Unreal. If you're familiar with that technology, great. If you're not, it's not that easy. So why don't we facilitate that? Because in the future, if NASA or if you guys want to do that again, that tool will be ready. And Roger said, yes, let's do that. So we spend the next 5 months exploring Unreal and creating tools, creating plugins. Arcturus helped us a lot because without their plugin, the volumetric video inside Unreal would be useless. So we created those plugins. And then all of a sudden, we had probably the last week of the project, the entire new blueprints that we created. And I said, Roger, tomorrow we'll have a scenario. And we're like, how? Because we've been working 5 months. He said, yeah, so we're going to build tomorrow. So basically in half of a day, we brought all the assets together and we were able to present it to Roger. So with that said, I would like to move back to you.
Thank you, Rodrigo. No, that's really great. And we have a video to show you some of behind of the scenes, all the work that was done behind this. But before I show the video, I'd like to really talk about what to me was like a very key point for the success of this project, right? Because it was not that we in academia, right, researchers, physicians, educators said, okay, we need this, and then 6 months later, you come with a product, right?
Yes.
We had to learn everything you do in the production part, right? Because when you say, okay, branching narrative, we're not talking about like a branching narrative of a story of like a movie or like entertainment. We talk about the story of a disease and the story of our body, how it responds to certain actions from a health professional, right? So that's the different type of storytelling that the branching logic makes sense because it's how the world works, right? We make decisions, things happen, and there is a cause effect on that. But that mechanics needs to be consistent to medicine and to space medicine, right? So instead of just saying, okay, this is what we do, translate that into the product, right? I'm sure we would still be here 5 years later refining that, right?
Absolutely, yeah.
What we decide to do is that our team needs to learn not what you do, but how you do things, right? You need to learn about storytelling. You need to learn about XR, what's possible, what's not possible. And what we did is that, for example, the first storyboard, right? I created that as if being a physician, right? Learning what is a storyboard, what that makes sense or not. Because here I need to put that in context for what happens with your blood pressure, of your heart rate, of your patient complaints when you do this decision or when you make that other decision, right? And the same thing happened also, right? You guys need to learn about, okay, how medicine works, because our goal here is not to entertain people, it's to improve their learning outcomes. The learning outcomes of medical knowledge and medical skills, right? So working together and learning from each other, I think was really, really key for this project for us to be able to do this like in very few iterations and come with the final product. So I'm gonna show here the video that gives us a very good
Okay, this is a 2 years in a make project. We've been contacted by Harvard Medical School about 2 years ago. So basically, we capture the entire strata simulator. It's a replica of what it is in International Space Station. And then we did it in photogrammetry. Now we have a rough model of everything. Now we just need to capture the actors. So that's what we've been doing the last 2 days. So this entire idea took that long because basically in the process, we got engineers, NASA astronauts, PhDs, professors, and doctors, just to kind of give us everything we need in order to create the scenarios. Now that we had all of the questions and we create everything, all the mood, then was the time for us to shoot everything, and that's what we did today.
We're finally here. This is, I think, the last piece of the puzzle from our long journey. We got this call from our friends at Harvard, Roger, Stephen, Chuck. Called us about this incredible mission to start looking at new ways of doing training simulations for the future of space travel.
We are just like finalizing the entire project in terms of capturing volumetric videos. Of course, there are a lot of work on the development part and also on the research, in which we're gonna have a lot of participants coming to our simulation center and really using the virtual scenarios we're creating here And with that, we'll be able also to test a lot of like research hypotheses that were like the initial motivation for all of this is of course to develop new and cutting edge things, but also to test those new technologies with robust methodologies. And this team, or multidisciplinary team, right? This work could never be done by one person or one institution. It's really a collaboration between multiple institutions that put together a lot of like expertise. So we have like physicians, educators, psychologists, technicians, and computer science, and producers, directors, and everyone who really can put their expertise towards this project.
To be part of this incredible force that thinks beyond the obvious and thinks and asks questions of how we can do things in a different way.
Okay, so that's our like behind the scenes of what we did, and it's very important that this project ended in 2 months ago in March, and as I mentioned, this is a research project. So what we did in this like past 6 months was really to test and evaluate the scenarios, right? So we are evaluating the usability of the scenarios. We are evaluating the level of engagement and immersion of participants while using the scenarios. In our lab, we use digital biomarkers. So we are having participants with EEG, electroencephalography devices, electrocardiography devices, skin galvanic response, while they are playing the scenarios. And we are now measuring their physiological responses at the brain and autonomic nervous system level, how they react, how they are immersed with the scenarios in different modalities, right? So we were able to deploy the same scenarios with the same branches, exactly the same thing, in 3 different modalities. Desktop-based, that you can use like a computer to play the scenarios. Immersive VR, that you can use a headset, and we deployed that for HTC Vive and Quest 2. And also for AR. So we can go to the real spacecraft and have those digital assets overlaid in that image using tablet or a cell phone and play those. So what we're doing now is really using randomized trial to compare the 3 modalities, right? We're trying to understand, is that difference in the level of immersion, the level of presence? Is that difference in the level of cognitive load of those learners in different modalities? And more important, what is the impact on learning outcomes? So we're measuring their knowledge after the training in different modalities and trying to understand better what are the implications of using different modalities of extended reality, AR, VR, and desktop-based. So that's the next steps we're doing. We're now doing like data analysis of that. Now I want to make sure we have some time for questions. We have 15 minutes, but I really would like to ask each one of our panelists how they see the future, right? So we learned a lot of things through this project. A lot of things changed in the XR world in these last 3 years, but how you see the future as it relates to XR medical training based on what you learn from this project, but also what we have been learning from the field. Let's start with Michael.
Thank you. In order to look at the future, you have to look at the past. And I did that. I struggled learning. As a kid, it was hard for me to learn. And Roger shared an experience with me when he said that he was a kid. He lived in Brazil. He didn't have the resources. So in order for him to learn, he would have to borrow someone else's book. He would have to erase the answers and create his own answers. That's where education currently is inaccessible to the masses because it's too expensive. Sorry, Harvard. Not trying to put everyone on the spot, but it is. It's inaccessible to most people. This allows a new form of learning, which is tapped into our core DNA. It's how we learn. It's how we put what we've studied, apply reasoning, and then now we apply practice, which I usually call pain. Through pain is how you learn. And this allows us the freedom to do that. This allows us to learn through practice and trial and error, which is how I've learned almost everything in my life that's impactful. And I think what we can do with this is move it beyond just learning or teaching. I think the next step for humanity is mentorship. It's how we all learned. The most impactful things we learned was through our mentors, through our parents. They understood our feedback. They understood when we were struggling. I was that kid that was struggling. If there was a teacher that could understand that, they could work with me and find new modalities to give me the abilities I can. If Roger had the access to the books, it could be amazing. So, and education is the most incredible form of freedom. Allows us to express ourselves, to understand the world better, and I think it's the most important thing. So this has been an incredible honor. And I do want to say something that's really important, because it's not just us on this panel that made this happen. There were flight surgeons, there was so much research that went behind us, and I want to also thank our partners at Sony. Sony gave us the ability also to capture a lot of the volumetric stuff, do a lot of R&D with them. And without their support, it would be very difficult to be on this stage.
Well, Michael, Rodrigo, how is the future?
Yeah, that's a $1 million question. For me, it's I've been working in VR since 2010, and I've always been an advocate for not only the use of VR for many different modalities, many different industries, but also trying to tap into, hey, maybe what we're doing inspire you to come along and help us. I was very blessed in this project that I brought my son, Luca, is here. Luca started as a volumetric video editor for this project with us. So I think it's like next generation. And I think this is so important, because without education, there won't be a next generation in XR either. So for me, the way I see the future is like we need we need this next generation of thinkers. We need them to help us using everything that we learn, that we suffer so much to learn, right? And how would they use this technology? I'm more interested in seeing how would they use or how I use, you know what I mean?
Yeah.
So, thank you.
Thank you, Rodrigo. Piotr.
Well, I'll be brief. What I love and I've been so passionate about is just the power of volumetric video from the perspective of this is a real person. It's not a CG avatar. It's not an animated character that you're engaging with in volumetric video. You're engaging with a real person. And that, to kind of tie in what Michael and Rodrigo are talking about, is how we all learn. We learn by engaging and connecting with other people. It's not necessarily through a book. It's not. It's through the teacher at the head of the class that you're engaging and learning. And that's what volumetric video offers and delivers. And that's what makes me so passionate and such a strong advocate for volumetric and for use cases like this one.
And in general, I'm very optimistic about mixed reality training as opposed to maybe passive video-based training. You know, if you look at, the ways that a lot of, police officers and others had been trained for a while, it was, by even if you go back to like driver's ed, when you watched videos in school and that was how you learned. Frankly, it's not the same as when you're in a real situation and you're under pressure and you're under the gun. Or when you're, interacting with someone face to face, the kind of tension or excitement that can bring into a situation. So what VR and AR training, I think, offer is this ability to have realistic, safe simulations that will better prepare people for actual situations that they encounter. And it's projects like this that are laying the foundation for the future of mixed reality training. So, my hope is that if we can continue to create hyper-realistic, effective simulations, we will better prepare people for real-life situations where they can be ultimately successful because they will have kind of an innate sense memory of that experience and remember, like, intrinsically the correct actions to take.
I have a question.
Yep.
What was your takeaway
Yeah.
from cardiac experience? What did you take away?
So my takeaway and how I see the future of like the project and everything that's going on, right? It's really that the extended reality. Think about medical education, right? That's my area of expertise we're on. I really see very, very rapidly extended reality being part of our regular training. Most of our training, especially if we can talk about like skills, medical skills, competence assessment, and acquiring, is based on physical simulation centers, right? Those huge physical centers, huge buildings, large equipment, and very expensive. And I really see like the next 3 to 5 years, we have the capability to do 50% of what we do now in the physical simulation center being immersive and in extended reality. In 10 years, I would say that 90%. Very few things will require us to do that, to do training in like a physical space. Now, why I think that's going to happen is not because the technology is cool and is interesting. It's because that's solving a problem, right? That's solving a current problem that we have now with like the physicality of the sim center, the geographically. We have training and institutions sending people from one country to another country to do training in a simulation center, right? Can you imagine like how expensive, logistically impossible it is for a lot of people? Yeah. And I think the access, right? With the extended reality solutions, we can really give access to people everywhere in the world. Great experiences, driven by storytelling, that's core, absolutely. Allowing people to engage and to make decisions in their scenarios. So I really see the future of medical education being like almost 100% through extended reality. Yeah, very soon.
The good thing will be that you won't have to take somebody else's book and erase the answers. You could rewrite your books.
Yeah.
Mm-hmm. You could rewrite the books and have your audiences be in it and learn through it.
Absolutely. So do we have 5 minutes for questions, right?
Questions.
Sounds good. So anyone has any question, please? Yep.
I have a question. So I think it's great you're doing the comparison studies for the different modalities, but my question is, have you delivered this to the TRISH program, and do they have any plans to embed this in the 40 hours of medical training for astronauts?
That's a great question. And we did a similar project with like volumetric and branch narrative for the DoD, Department of Defense as well. In a different project, they wanted training for military personnel when they are deployed in austere environments, right? All their training is also based in simulation centers. And when we develop this right now and get back to them and say, okay, what's the next steps, right? How can we adopt this? Because we created 3 scenarios, 2 for NASA and 1 for DoD. And the big issue we have now is scalability and how much it costs to create like 1 minute of these scenarios. It's still imperative to scale for certain applications with the technology we have right now. So the answer is it's not viable from an economic point of view to scale this for like 100 medical scenarios like next week. Our hope is that with all this development of technology, right, we could get the volumetric videos and all the technology around much less expensive, and then we can create all this great experience to like everyone in the way that's scalable. But right now, our conclusion from these 2 projects, when we think about scalability, is that still not there. Any other question? Okay. So thank you very much for coming here, for your time and for your attention. Thank you.
Thank you.
Thank you, guys.